If you wonder what you need to achieve to observe your OpenTelemetry Collector, then this episode is for you. Welcome back to the Is It Observable YouTube channel. Today's episode is going to be related to the OpenTelemetry series where we covered lots of episodes. In this channel, I usually try to cover most of the recent features provided by the OpenTelemetry community. And when building tutorials, I often use as much as possible one of the most important components of OpenTelemetry, and I'm referring to the OpenTelemetry Collector. Today's episode will answer to one single question: is the OpenTelemetry Collector observable? I mean, when working with the most popular observability project of the community, we may expect that we have the right observability data. Small teaser, this episode will present an amazing feature flag already available in our latest version of our collector. It's the extended telemetry support of the collector. If you enjoyed today's content, don't forget to like and subscribe to the channel. So let's see what you're going to learn out of this episode. We'll start by reminding what are the KPI, the things that we need to pay attention and of course observe when operating an OpenTelemetry Collector. Then we will touch base on how to enable the core metrics produced by the collector and how we can collect the logs produced by our own collector. Then, of course, we will explore this feature flag feature that will extend the observability data from our collector, and especially the new settings available on the telemetry side of the collector. When discussing with a couple of projects or architects, I'm often surprised to discover that projects don't even put the right observability in top of their OpenTelemetry Collector. I mean, if you are using an OpenTelemetry Collector, it technically means that you are collecting observability data to transport it back to an observability backend of your choice. This data is going to be the gold, the heart, the most important assets for the SREs in platform engineering. So anyone who is involved during an application crash or a production disaster rely on that data. So lots of critical role or task within our organization depends at the end on the actual health of our OpenTelemetry Collector. If the collector crash, then there's no data coming in our environment. So what are the things that we need to pay attention? Well, no surprise, similar to any critical applications, we need to report the resource usage of our collector, so the CPU, the memory, the potential CPU throttling. Then, because it's a Go component, we'll also need to have an eye on the behavior of the garbage collector. And of course, we have a pipeline running on the collector. And if we have an issue in this pipeline, for example, a Prometheus scrape issue, or we are mistransforming the data, or the exporting is having trouble to reach the backend, then it's going to be a problem. So lots of data could be rejected from the backend, and we are blind. So we need to understand why we don't have logs anymore, why we don't have metrics anymore, why we don't have enough traces anymore. To understand the actual pipeline health, we usually gonna rely on the logs produced by the OpenTelemetry Collector. So at the end, we'll need metrics and we need logs, so we could basically use our collector to collect those informations and send it back to our backend. In case of resource usage, the collector has a host receiver that will be useful for the bare metal environment, where this receiver will collect resource usage related to the process running in the server hosting the collector. In the case of Kubernetes, we could basically utilize the Kubernetes cluster receiver, the kubelet stats receiver that will report the health of our workload. In fact, all the workload of the cluster. But if you already have a Prometheus operator, for example, you may probably have kubeset metrics available, node exporter. So we could basically use the Prometheus receiver to scrape all the metrics exposed by those exporters to report the health. And last, if you're using any observability vendor solution of the market, you probably have a solution that they have baked that is reporting health and resource usage of any workload within a cluster. So which means, depending on which solution you're using, you can pick and choose which receiver you will need to use to report the health of the resource usage of your collector. In the case of the collector pipeline health or failure or whatever behavior, we will basically need to grab the logs produced by the collectors. So no surprise, we will simply use the file log receiver that will be able to read our own logs produced by the collector. And that will be true for the bare metal deployments, but also for Kubernetes. In Kubernetes, the only difference is that you need to have to mount the right volumes to the workload to be able to read /var logs pods. And last stuff from the resource perspective, for the garbage collector, we don't need to do much because at the end, the core metrics produced by the collector will expose by default garbage collector behavior as a default metric. So with the logs, the hosts, and the garbage collector, you will have a minimum understanding, at least from a runtime perspective, of what's happening on the collector side. But you will need to figure out what is actually going on in your pipeline. I mean, you want to understand how much data is coming in, how many metrics, how many traces, how many logs, how many of them has been processed, and last, how many of them has been exported. I always recommend to create 2 KPI, one related to the number of records exported versus the number of records received. This ratio will allow us to understand the percentage of data processed and if we are losing any data during our transformation. I mean, it could be completely normal to drop data because at the end you will probably sample some traces, you will probably filter some metrics, you're going to filter some logs. So I will create the ratio, follow our pipeline and adjust the target of that KPI based on the observation that we've made through the sampling decisions and the various filtering mechanisms that we have implemented. Another important KPI is to keep track on the quantity of data exported from the collector versus the quantity of data actually received in the backend. So technically, this KPI is supposed to be at 100%. If not, then it will help us to understand that either we have a communication issue or our backend is rejecting data. When using the collector, the community recommend always to use 2 processors in our pipeline. So we have the memory limiter and the batch processor. Memory limiter will always be the first step of our processing pipeline, and batch should always be the last steps of the pipeline. You may ask yourself, but why? Well, memory limiter is the processor that controls the memory usage of our pipeline and avoid out of memory situation. That is why we need to have this processor as the first step that will fix the limit during the processing tasks. And last, we have batch that will create a batch of observability records before exporting it. The batch processor will also compress the records, so at the end, it will optimize our network communications with our observability backend. One important aspect with the memory limiter, it has a notion of soft limits and hard limits. But we don't go into details, we did an episode about this, so check it out, the link is here. If the memory reached the soft limits, then the memory limiter processor will start refusing data. So this is why we need to keep track on the number of metrics or logs or traces that are dropped in the processor to identify that we are in a situation of reaching the memory limiter settings of our collector pipelines. The other important aspect is that exporting data is done every X seconds. It means that the collector has a queue to store the signals before exporting them. This is very convenient, especially if we have a communication issue where the exporter will retry to send the data. The collector has 2 core KPIs, so exporter queue size and exporter capacity. So we should create a ratio with those 2 metrics, so the size divided by the capacity, to see the actual usage of the queue. And last, we need to keep track if any signals has been refused by any receivers of the collector. At the end, it will help us to keep track on any potential data loss between our internal components, so pods or whatever, and our collector deployed in that cluster. To report the actual health of our pipeline, we need to collect the internal collector metrics. So the question, how do we do that? To enable the metrics produced by our collector, we will simply need to enable the telemetry. By enabling this, the collector will naturally produce the collector pipeline in KPI that we discussed, and also the garbage collector KPI that we discussed. This will be possible by adding in the service sections the following settings. Here it is. So you see services and then telemetry, and you make metrics, and you put the address and the port. It means that in this case, the collector will expose Prometheus metrics on the port 8888. Enabling is one thing, but we need to collect those metrics from our pipeline. For this, we will use the Prometheus receiver. So here is an example where you see we have a scrap config that collects the actual endpoint that we enabled on the telemetry aspect. And then of course, those metrics will be managed by a metric pipeline, where you can imagine to enrich the data by adding Kubernetes metadata, for example, drop few metrics, convert them into Delta if you have a Delta backend. So here is an example of a metric pipeline. In this case, we go with memory limiter, transform metrics, filter, Kubernetes attribute processor, and so on and so forth. So by doing this, you will send internal metrics of the collector. That includes, like mentioned, the garbage collector metrics, the various data refused, accepted, or dropped, or whatever. We still need to figure out the log perspective. So how do we collect those logs? For the logs, like mentioned before, we will simply collect the logs of the collector using the file log receiver. So here is an example of a file log receiver configurations. This configuration will read the logs and extract metadata from the path of the file. And here it's a Kubernetes example. So each log of our cluster are stored in the node in /var/log/pods, and the metadata is actually available in the file path. So in the file path, you get the namespace, the pod name, and so on. Collecting logs will require to mount these volumes to our collector, of course, and run the collector as a daemon set to collect all the logs from all the pods, and of course, our collector as well. Out of just collecting the logs with the file log receiver, you will still need to add metadata, like enriching with resource attributes to say this is the logs coming from collector number 1 in this geo, whatever. So adding extra context to the actual logs collected will be helpful, especially if you're operating several collectors within your environment. One very exciting thing that the community has been working on is improving the telemetry sections. For now, as you saw previously, you can enable the production of the internal metrics, but it will just expose the Prometheus export. So you will still need to scrape these metrics and have them back in your Observability backend. So to resolve this, the community has delivered since several releases. I think it's the number 0.9t. I'm not sure. So if you know the exact version, please drop a comment to this video with the exact versions. This feature will provide more configurations into our OpenTelemetry objects that we've just seen. It will be true for our metrics, but not only, also, the most exciting things is for traces. Now the collector is able to generate traces. I was waiting so long for these metrics to be able to keep track on the exact time spent on each processor. And now it's available. I just love that. Thanks for this, it's just fantastic. So how can we take advantage of this feature? Well, first, we need to enable this feature. Like I said, it's already available in our collector, but it's turned off by default. So we need to enable this feature. So how do you do that? Very simple. When in the deployments of your collector, you will have to add an extra argument. So here is the argument that will basically enable the OpenTelemetry SDK configuration for the internal metrics. So adding this will enable this extra feature, but now we need to configure our collector to generate the data that we need, similar to the way we enable our Prometheus metrics using telemetry objects. We will add in the service sections, again, the telemetry objects that will support two types of settings, one for the metrics and one for the traces. So here's an example. And you can see here, we are enabling metrics and we're exporting it through OTLP, and we are exposing it locally. We do the same thing for the traces, where we are producing the traces and we're exporting it directly to a backend. So this configuration of telemetry, the configuration of the telemetry object for traces and metrics follow a lot the notion of traces and metrics concept provided by the OpenTelemetry community. In the metrics, you will find the periodic, that allowing you to define the interval between each metric projections. And within that periodic objects, we will define the actual exporter address and the actual protocol. So it could be OTLP or HTTP. And similar to the configuration of our exporters that we do in a receiver or exporter, we can define the endpoint, the protocol use, so it could be HTTP, it could be a gRPC. We can also enable the usage of certificates. We can also configure specific headers in case we need to use API tokens to send the data to a backend. And for the metric perspective, we also have the options to use temporally aggregation preferences. So it could be either delta or cumulative. Again, if you want to filter or to do some enrichments on the data or a drop or whatever you want, you can clearly imagine to produce the metrics and send it locally to your collector. So then the metrics or the traces will come in the collector and will go through your traditional pipeline that you may have already designed. Again, this is what I've done with the metrics where I'm sending it local. On the traces side, it's the same thing. The only difference is that this notion of exporter is not under periodic because that doesn't make sense. It's under batch. Okay, so now we say we have the metrics, we have the traces, fantastic, but what about the logs? Can I enable in the telemetry objects the notion of log productions and the destination of the logs? Well, it's not yet there. It's pretty much related to the coverage of OpenTelemetry logs for the Go language. So I may assume that we would have the similar settings in the future for logs, but for now we need to wait the support. So we will still need to use the file log receiver to collect the logs from our collector. As usual, for this episode, I prepare a GitHub repository with a couple of tutorials and examples, and I have an example with a couple of collector pipelines with the telemetry objects configured to send metrics and traces. For the logs, I'm using the file log receiver as usual. So let's start by looking at the trace produced. As you can see here, we have one single trace per exporter. So one for logs, one for traces, one for metrics. And then we have, if we take a look at the trace, we can see that each step of the pipeline is not a span, but a span event. So it's there, we have the information, but again, it's a bit hard to visualize. So maybe this would be improved in the next coming releases. Then I have prepared an example of a dashboard that reports my collector health. I'm adding sections where I'm parsing the logs from the collector to retrieve all the potential metrics that are being dropped by the Observability backend. It will identify the metric name that is rejected, and that will help me then with this information to adjust my pipeline and maybe process differently the metric, or simply drop the metrics if I'm not able to do. And if I scroll down, you can see that I also added this notion of resource usage. So here, it's not the collector collecting the metrics itself. It's basically the Observability solution that is collecting it. So I just displaying basically here in my case, the CPU usage and the memory usage. That's it for today's episode related to observing your OpenTelemetry collector. So at the end, do we answer the question, is the collector observable? I will say clearly yes. We have the right metrics in place, we have the right logging in place in case of errors, and last, now we have traces in place for our pipeline. So yes, the collector is observable. For the metrics itself, the production, sometimes we have all the dimensions with the right plugins used, the metric drop by plugins, and sometimes for some obscure reasons, we don't have all the plugins. So maybe it would be great in the future that every single plugins respect a format of producing metrics. So then everyone has the right dimensions, the plugin name and so on. So then we can do more analytics on the steps, where it's been dropped, where it's been refused. So then we will be more deeper and precise on the error and make the right decisions. I'm really excited about the feature flag feature exposed by the OpenTelemetry community. It's very exciting to see the spans. I usually was putting timestamps and it was very imprecise, and now having the exact span events with the timing of each steps. It's so great. I love it. I will still love to see a span instead of a span event. Maybe this has been designed that way because maybe it's lighter to produce span events than create spans within the collector pipeline. So of course we don't want to add extra overhead to our collector pipelines. So I think if it's a performance matter, I don't care. We have the data, and that's the most important aspect. All right. So if you enjoyed today's content, don't forget to like and subscribe to the channel. So see you soon for another episode. Bye.